So we will display what, and the what simply returns a very simple mechanism. It returns the message that we were able to supply, right? Error vector is empty. Okay, so let's test it, except that this is a standard library facility, runtime error, and we need another header file for this. We have to say include std except, one word. So with this, right, with this std except, and with display elements that selectively throws runtime error if it decides to do so. This is what we're going to do. We're going to essentially replace our if-else statement, which was trying to search for true or false before. Now we say try calling this function. If everything is okay, the execution will continue over here, and then we simply return. But if we try this and something goes wrong, such as an exception is thrown, then we will catch this exception right here, right? So notice the ampersand is just simply a facility to not to duplicate this error object. Is called a reference, but that's the syntax that you have to use. And this is us catching this error. And the what member function inside this exception runtime error exception object will simply provide the error message that we were able to capture. And we say display elements failed. Let me build this, right? I misspelled something. Return true. Okay, fine. Return false. Fine. Let's do again the build. Okay, so this time everything is built fine. And quickly run again. I press Ctrl Z immediately to keep the vector empty, and this is the outcome, right? So this is what I got printed. Let me show you right here, right? So clearly what happened was that we resize my windows a little bit, right? So what happened was that we went to our main execution order, and we were saying display elements and pass our vector, which is empty because we did not enter anything in it. Because the exception was indeed thrown, because the first thing that we did inside the function was check this condition, whether it's true or false. If the vector size is 0, which means it's empty, then we throw this runtime error, and pretty much our chance to examine the error is this thing inside the parentheses. Whatever we place inside here will indicate information about the error. So this works, and again, the advantage of it is that if this display elements, for instance, I decided to change it and return instead vector size like this, right? I could from it I could return a value such as this vector size. So this function display element returns now it returns number of elements displayed, right? Returns number of elements displayed. You see, now I am not crowding my return facility with my error reporting. My error reporting goes through the channel of the throw statement, which has to throw an object that contains the string which I have a chance to process later on, or right? And alternatively, I just return whatever I decide to return from my function. So my function return type is integer. I decided to return the size of the vector. So this time I can analyze all of this. At the time when I call my function, I can, for instance, say int elements count, right? Elements count. So I can now get value from display elements, and everything is okay. Comma. Processed this many elements count, right? So we process this many elements, right? Just to make it reasonable looking. Otherwise, we throw this error and we say display elements failed. How about we change the wording to say failed to display elements, to display vector elements, just to keep everything clean. Okay. So you see that now the function is capable to return the value if everything is okay. But alternatively, it can throw this exception because it wants to. So let's talk about the advantages of using the exception. Right, let me just collapse this split here. And the advantages are if, for instance, I use this Boolean true or false approach, which was the original thinking, oh, maybe I should try to see if there was an error by simply returning true or false. Returning true or false was forcing me to use return value to immediately react to an error. This time I have a choice. One choice is that I can use this try and catch statement, right? The structure, control structure, try and catch, which is designed to process exceptions. But alternatively, I can say that let me just catch any exception at the end. So instead of doing it like this, let me change this main function one more time, copy, and paste it again and say this is whatever version 4 or 3, whatever we used already, right, today. And so instead, first of all, let me change it like this. Get rid of exception processing altogether and run it without any paying attention to the exception mechanisms, the possibility of exceptions. I build this, right? Everything builds as exceptions did not exist. I run my program. So I say 1, 2, 3, something else, Control Z, everything works as expected. This output looks like this. This is my latest output, like this, right? Everything is working, and this is my latest version of main function, which simply makes a call to display elements and tells the user how many elements have been processed as a result of this output. But let's try to provide an empty vector to this program. So I don't have to rebuild anything and just run the program again. pressing Control Z instead of entering anything and hitting enter, and you see that it just gives me that there is an error that was generated and I can abort the program. So the program actually starts to behave exactly as the assert mechanism, right? So in our debug build, when exception is not caught at runtime, you see that there was a message box that says there was an error. However, this error does not provide any information about location of the error. One significant issue with throw is that it does not report where exactly this error was. There was no information. If you notice, this message box just basically said the program misbehaved, it basically crashed. So uncaught exception, right? Uncaught exception results in program crash, but it's actually much worse than the assert. Assert at least told us where it crashed. This thing is just stops the execution and program is thrown out of memory, right? So this is the behavior if we choose ignore exceptions, and so this is probably not a very good choice. So this is what we can do alternatively. We can use the entire body of the function main to say try this whole thing, right? And then if something goes wrong, remember we had this example. So here we can do the same thing with main, this time with main. Now notice the opening parentheses of function main now has, not parentheses, the curly brace or the bracket here, right? So it has the try control statement, and this is the closing brace of function main, and now it has the catch part, and it says catch this runtime error, and how about we just say now program failed, right? Program failed. Okay, so we say this program has failed. So let's run this again. Have to rebuild it and run it again, and this time again I will press Control Z, hit enter, and we still get information that the vector is empty, right? So I'll just indicate it right here next to our code. It says error vector is empty. This is the information that we provided by this string that we decided to add to the runtime error when it gets created. And so we report this error by saying what happened. The only problem here is that if I have many places where different errors are detected and different exceptions are thrown from the program, so I lose connection with the original error. You see the issue? I want here to not just say some message. I would like to provide the same information that the assert was able to provide, which was the full path to the source file and the line number on which this error has occurred. So in other words, I don't want to lose my connection to the place where error happened, because look what happened. Originally, the main function started, it did a lot of things, it then decided to call another function, the execution went into this function right here, and then eventually something went wrong over here. This runtime error was created and thrown by the throw statement. Eventually, we came back from, by this throw statement, the execution of display elements got interrupted, and we ended up going from here directly into the catch statement, and then here we decided to print the information but we certainly lost track of, or at least, you know, I mean, my only choice right now is to search for these strings and see where strings like this, error, vector is empty, to try to locate the string and decide that maybe that was the place where the error was generated. But it's not a very convenient thing. I want to be able to report it instantly. I want to instantly print right here which source file and which line number resulted in the error.